Hey guys, and welcome to another Mr. Fourth Dimension video. We're doing the Geo project, and last time what we did was we set up the circle area and circumference and arc length sector area. I've gone back and fixed the spelling on circumference, which I'll make sure is clear when we get to the code. And today what we're going to do is we're going to do collisions between two circles, or collisions like a point, detecting if a point is inside of a circle. So let's get to it. The spelling error I made was that I spelled this like the word France. It's not. It's circumference, like that, and it's not wedge area. It's sector area. Is the usual mathematical term for what I was doing there. So we're going to do collisions, and after this I might want to start working on how we're going to visualize this a bit. So this might be the last purely geometric thing we do for a bit while I work on a new visualization scheme. I have an idea for how we might do it, and we'll look at that next time. But for now, let's do this collision math. First, let's do the point in a circle. That's not too hard. One thing we've got to think about is what it's going to return, because there's basically three values. It's not just true or false, but there's three meaningful values you might want to know. You want to know if the point is outside of the bounds of the circle, inside the bounds of the circle, or exactly tangent, exactly on the line of the bounds of the circle. Right? So, to that end, I think, and we're all, like, lots of collision stuff might want something similar, so I think we want like an enum for collision result, or enum collision geo collision I don't know what we would call that classification. It's a geo amount, overlap type, collision type, something like that. So no collision will be 0, so that we can do an if on these to see if, like, if we just do the if, 1 and 2 will be tangent and full overlap. So that if we just want to know if there's any kind of touching, which is often what you want, and then if you want to know specifically is there tangent or specifically is there overlap, then you can ask for those with a simple equal equal. But anyway, collision type, geo, we'll call this circle, or point in circle, or point in circle, makes sense. And then we need the definition of a circle, which is going to be a center point, a center, a radius, and a point. Right, and this is where this part here, the point radius, might end up, that might make more sense if we do it as a struct. So before, we were just doing sort of general circles where we didn't need to know their location, so it turned out that making a struct for circle wouldn't have helped. But here, where we might start seeing that we pass these two things around together a lot, and if that's the case, then we'll pull it out as a struct. But now, to find out if two things, if the point and the circle are overlapping, tangent, or non-overlapping, we got to do a little bit of math. So the trick here is, with a point it's kind of easy with a circle, because either you want to, the point is either the distance between the center and the point will basically tell us what we need to know, because if the distance is less than the radius, that's an overlap. If the distance is equal to the radius, that's a tangent, and if the distance is greater than the radius, that's a outside of the bounds. And then there's also the little matter of if we want like an epsilon on this, because what if the distance is rounded up for the point and then they're down for the radius, then they wouldn't be equal. So the tangent gets a little bit harder when we want to make a very small epsilon of error, like rounding error. The other thing to think about is, do we want to take the distance and compare that to the radius, or do we want to take the squared distance and compare that to the squared radius? The reason you might want to do that is because, like I've said before, when we did the squared stuff, is that, or the square distances, computing the square root is quite expensive. Taking the square of the radius is less expensive than square rooting the distance, so that's actually what we're going to do. So first we need the distance from the center to the point. We're going to get the squared distance equals geo distance squared from center to P. Then basically we're going to do a switch on well, can't do it that way. If the radius is greater than the squared distance, well, let's do it in the other order. If the squared distance is greater than the radius, then that is collision none. Else, if the squared distance is less than the radius, that is, oops, that should be an if, return geo collision overlap. Otherwise, it's a tangent, right? Collision, oops, there we go, collision tangent. Now what we want to do is figure out what to do with this epsilon value. The thing here is, if we're just picking a very small epsilon value, it shouldn't matter too much, because what we're trying to do is pick something that sort of says, hey, if it's off by this much, let's say that they're at the same place. And sometimes what that might have the disadvantage that sometimes it says they're at the same place when they shouldn't have been considered the same place. Because if you had done the math from the original numbers, they really wouldn't have been in the same place. That epsilon just happened to catch them and put them in the same area. The other weird thing is that since we're squaring this, it would be different if we were just doing distances, but we're actually squaring them. So I don't know if it would be technically more correct to do something where we, square or square root the epsilon, depending on whether we're doing greater than or less than or something like this, right? If we need to adjust the epsilon and make it bigger on the outside than it is on the inside because of the fact that we're comparing squared distances. But it's just supposed to be catching errors anyway, so I don't mind if it's a little bit wonky on the math, and if it becomes a clear problem, or if I'll put a note on here, and we'll make sure that we look at this in more detail later on. Should the epsilon be adjusted because the distance and radius are squared? Which reminds me, we have to actually square the radius. Like so. And then let's do, this can just be, global const geo epsilon error. No, we're going to do specifically point in circle. I'll put the word epsilon right here. Epsilon point in circle equals 0.000001. Right, so we'll make it a nice tight error margin. Geo epsilon point in circle is less than. So there we subtract it because otherwise it wouldn't be doing us any good. Alright, we're trying to prove that this thing is less than this, but if it's not less than this with this extra little bit of epsilon, then that means that it's so close to the radius squared that we maybe should have said tangent. Great, so that is our point in circle function, and that basically has the job of telling us if the point P is within the radius of a circle centered at center. Right? Okay, so One other function we want is if two circles are overlapping. And this is where I don't know if we just want one epsilon for the whole program or distinct epsilons. Maybe we should do it like this. Put it in the scope of the function like that. So we don't have these crazy long names, but they are like local to that function, because maybe different functions want different amount of epsilon. So now this is going to become C1 for center 1 and R1 for radius 1. This is going to be circle, circle, collision. I'm using the word collision. I don't know if that's necessarily the best choice, because that sort of sounds game-ish, and this doesn't necessarily have to be doing a game. It's not necessarily a collision if they're not moving and stuff like that, but I just really mean that how are these shapes oriented? Are they overlapping or touching tangentially or nothing at all? And then here what we have to do is just a tiny bit different. We want to take the distance between the two centers, first of all, and then what we want to do is take the total radius, right, which is going to be R1 plus R2. That's like the total of both radiuses. So if you imagine like the two circles have these 2 points and they each have a radius of R1 and R2. If the distance between them is exactly equal to R1 plus R2, then they're tangent. If the distance between them is greater than R1 plus R2, then they're not touching at all. And if the distance is greater or is less than R1 plus R2, then they're overlapping, right? So it's pretty straightforward. And then it's the same idea as before, that we're just going to square this. Actually, I should square this up here that way too. Radius. Because otherwise it might actually be doing that multiplication twice. So that change I just made was to say square it once and then use that same variable in both places. Don't interpret this as something you need to square twice. I don't think it would. I think it would optimize that out in an optimized case, but we might as well be explicit so that it's easier for it to see what we're doing, even in a debug scenario. And then we just take the squared distance and compare it to the total radius, just like before. And we do the geo epsilon. Actually, we can just copy this code because it's so similar. There we go. Now let's just turn these into total radius. Alright, so now we have a function for telling if a point is inside of a circle, and a function for telling if two circles overlap. And they each have 3 return cases. So we're going to make those 6 test cases real quick. I think we'll just pull all of this out. First, let's do if geo circle or point in circle, if point in circle, and let's see, we need a center, geo point 2D, and then we need a radius, so that'll be 3.5. We'll center this at 1, not 3.5, 3.f, meaning actually 3. Then the f just says do this as a float, not a double. And then another point, and I'll make the first one, let's see, if we want it to be inside that circle, we put it right about here. That should be within a radius of 3. So, here I'm going to reduce the length of this line a bit. If that equals geo collision overlap, then printf test1 good. Right, so we're basically looking to get a bunch of good signs and no bad signs, because we're going to set it up so that we expect the signs that come out to be good. So if we see anything bad, that means something was wrong in our expectation, either the math in the test or the math in the function. Okay, so the next one's going to be tangent. So let's see, I'll try a negative here. and then we just are going to put this on the same y, right, and in x we'll move it to the right by 3, so it'll be at 2, and that should make it tangent. Alright, and then we want the last one to be none. And so maybe what we do there is we make this a -5, so there's no way that those should be in the same area now. They should not. There's no way that point should be in the circle, if I'm being precise. Awesome. So now let's do the same exact idea for circle-circle collision. If geo-circle-circle collision, and now I'm going to copy this right here, which makes a circle, right, and we'll make 2 of those, and we'll say if the geo-collision is an overlap, right, and then let's see, if we put the first one, let's put it at -1, -1 with a radius of 3, and put the other one at +1, +1 with a radius of 3. Those, let's see, 2 squared is 4, plus 2 squared is 4, 8. Square root of 8 is, yeah, they should totally touch each other. Should totally be overlapping. So, let me grab all of this. That should be test 4. Alright, let's see, how are we doing on time? Okay, we're pushing it a little bit, but we gotta get this done to call it a day. 5, 6, 6. Now, we need these to be tangents. Okay, so the distance between these won't be nice. Let's put this at, 2, 2. And now let me think of something which is a Pythagorean number that I like. 3, 4, 5 is 1, right? 3 squared is 9, 4 squared is, yeah, that makes 25, which is 15. So if I put this at 3 over and 4 up, right, that would look something like this, and then I make sure that the sum of these two is 5, that should be tangent if I haven't messed something up in my math. If this isn't working when I run it, then that means we have to look at it next time. So this one, a unit circle does not reach all the way from 0, 0 to -1, -1, or all the way from 0, 0 to 1, 1. So there's no way these two should be touching. So we should get nothing but goods if I've done all my math right in the test and if the functions are correct. Let's see what we got here. Conversion from double to constant, possible loss of data. You're so right, that should say real 32, that should have an F. Run. Oops. Run. It says they're all good, so I think we did it. Hope this has been interesting. See you guys next time.